Have you ever looked at a star and knew, for a fact, that the light hitting your eye left that star before you were born? Better question. Have you ever stood outside on a quiet night, looked up at Orion's shoulder, and felt like something ordinary was happening when something absolutely extraordinary was already underway half a millennium before your eyes reached for the sky? Because right now, tonight, the light arriving from one specific red dot in Orion is roughly 650 years old. Some of those photons left that star when Joan of Arc was still alive. And inside that ancient light, swirled into the spectrum, scientists have just decoded something they have been searching for since long before most of us were born. Something that rewrites what we thought we knew about the most famous dying star in the night sky. If you have ever wanted to feel what real discovery feels like from the inside, stay with me. And if you have not already, tap subscribe and ring the bell right now. This channel exists for exactly this kind of moment, the moment a single finding rewires how you see the universe. Lock in. The whole thing is about to land on you. The story starts with a single dot, a faintly red star in the upper shoulder of Orion, easy to spot if you know where to look. People have been staring at it for thousands of years. Ancient skywatchers gave it a name. Chinese court astronomers logged it as one of the brightest, moodiest stars in the sky. Polynesian navigators used it to cross open ocean by starlight alone. Medieval astronomers wrote it down as a thing of wonder, a star that visibly changed brightness over months and years, which made it almost mystical to people who had no idea why. And for all of those thousands of years, every person who studied it ever made the same quiet assumption, that the star was alone, a single, enormous, ancient ball of gas, slowly burning through the final reserves of fuel in its core and getting ready, at some point in the very deep future, to die in the most violent way a star can die. That star is called Betelgeuse. And what astronomers confirmed in early 2026, using 8 years of continuous observation from the Hubble Space Telescope, combined with data from some of the most powerful ground-based observatories on Earth, is no longer consistent with that assumption. Betelgeuse is not alone. Hidden inside its outer atmosphere, orbiting through the red giant's enormous outer layers every 6 years like a moon through cloud, is a second star, smaller, hotter, a blue-white main sequence companion that nobody had ever directly seen until very recently, and its presence, the gravitational pull, the wake, the slow stirring of an atmosphere that spans hundreds of millions of miles, is forcing scientists to rethink the timeline of one of the most anticipated astronomical events in the entire history of human observation. Before we get to what that means, you need to feel the scale of the star we're talking about, because dying star sounds almost gentle, almost poetic when you say it out loud. The reality is considerably less gentle. Betelgeuse is a red supergiant, and that is a category of star, not just a description. These are the largest stars the universe is currently able to build. When astronomers sit down and try to measure one of them, they quickly run out of normal numbers. Betelgeuse is somewhere around 700 times wider than our sun, in some estimates and some wavelengths wider still. And here is the comparison that really makes that land if you let your imagination hold onto it for a moment. The sun is not a small object. It is so massive that 1 million Earths could fit inside it. If you remove the sun from the center of our solar system and dropped Betelgeuse into its place, the surface of Betelgeuse would not just reach the orbit of Mercury. It would not just reach Venus. It would not just envelope Earth. It would not just consume Mars. It would extend out past the asteroid belt. In some readings of the data, it would swallow Jupiter too. You would be left with only Saturn and the outer planets circling safely outside the body of the star, one single object sitting where our entire inner solar system currently is, on fire, visible with the naked eye from more than 600 light years away. If that does not at least briefly stop your breath, hold the number a second longer. Betelgeuse is so large that if you placed it where our sun is today and you stood on a planet circling our sun from where Saturn actually is, it would fill roughly a third of your entire visible sky. It would be wider than your thumb held up at arm's length. That is the size of this thing. And it is dying. The dying is not new news. Astronomers have known for decades that Betelgeuse is in the final phase of its stellar life. If you have ever wondered how a star dies, the short version goes like this. Deep in the core, the star is busy fusing hydrogen into helium. That fusion reaction pushes outward with incredible force. Gravity pulls inward with equally incredible force. For most of a star's life, those two forces balance perfectly, and the star holds its shape. But once the hydrogen fuel in the core runs low, the balance tips, the core contracts. The outer layers of the star expand catastrophically, hundreds of times beyond their original size. The surface cools, which is why red supergiants glow red rather than the white-hot blue of younger, heavier stars. And the star begins to pulse, slowly, rhythmically, breathing in and out across decades, getting brighter, dimmer, brighter again. Eventually, when the core runs out of fuel entirely, The entire structure collapses inward in less than a second, then rebounds outward in the largest single explosion the universe produces, a supernova. When Betelgeuse finally goes supernova, it will outshine a full moon. It will cast shadows on Earth at night for weeks. It will be visible in broad daylight. It will be the most spectacular astronomical event in recorded human history. And the only thing standing between us and that moment is time. I want to pause the science for 1 second and tell you something personal about this channel. We do not run ads at the front of the video. We do not stuff these scripts with filler. We do not pad the runtime. We do it because the kind of people who watch this channel come here for the reason I think you are here right now, to feel something about the cosmos, not to be sold something by it. If that is resonating, leave a single sentence in the comments telling me where you're watching from. 1 sentence. That comment does more for this channel than anything the algorithm can measure, and it tells me whether I should keep building this place the way I am building it. And if you have not hit like yet, that small thing, that one tap, decides whether the next person who is searching for exactly this kind of wonder can find themselves here. It takes half a second, and it changes everything. Now back to Betelgeuse. For years, the evidence kept hinting that it might not be that long of a wait. Betelgeuse was dimming and brightening in strange ways. Not the steady, slow pulse you would expect from a single dying star at the end of its life, but irregular flickers, big swings, and occasional outbursts of material from its surface. Some researchers began suggesting publicly that the timeline might be shorter than previously thought. Some estimates pointed toward decades, not thousands of years. The speculation got serious. Then, in late 2019 and early 2020, Betelgeuse did something that made global news. It dimmed dramatically. Its brightness dropped by roughly a full magnitude, falling to levels that had never been recorded in the modern astronomical record. The drop was so deep and so visible to amateur sky watchers that anyone who knew where Orion was could see it with the naked eye. Social media erupted. Headlines around the world asked the same question. Was this the beginning of the end? Was Betelgeuse finally about to explode? Astronomers scrambled. Telescopes around the world turned to look. Hubble turned to look. Ground-based observatories from Chile to Hawaii to the Canary Islands all pivoted toward Orion. And what they found, when the data finally came back, was not what anyone expected. Betelgeuse was not exploding. It had done something else entirely. Something that, in hindsight, was the first major clue to the discovery that would change everything 8 years later. The star had ejected a massive chunk of its own surface. A titanic surface mass ejection. Billions of tons of superhot plasma blasted outward, cooling in space, condensing into a dense cloud of dust that briefly drifted between us and the star, blocking its light. Astronomers call this event the Great Dimming. And what made it strange was the scale. The blast sent more material flying into space in a single event than our own sun puts out across an entire normal solar cycle. For a star that big, it was the equivalent of a single violent sneeze. A convulsion nobody had ever observed in a red supergiant in real time before. And then, slowly, Betelgeuse recovered. The dust drifted away. The brightness came back. The cycle of dimming and brightening resumed. The story on the surface ended. But under the surface, the puzzle did not. Why had a star that size thrown off such a huge amount of material in a single event? And why, beyond that one strange episode, were the regular cycles of dimming and brightening also acting so strangely? For decades, astronomers had measured at least 3 rhythmic cycles in Betelgeuse's brightness. One around 400 days, one around 180 days, another around 230 days, all of which map to known physics of a star simply pulsing, swelling and shrinking, breathing in and out the way red supergiants do. But there was also a 4th cycle, a long, slow one, running roughly 200 days, or approximately 6 years. And that cycle did not match any known pulsation model. It did not fit the simple picture of a single aging star quietly burning through the end of its fuel. Something else was driving it. For years, nobody could figure out what. Then, in 2025, 2 research teams working independently arrived at the same answer at almost exactly the same time. Betelgeuse has a companion. The case they built was this. Something roughly the mass of the Sun, much smaller, hotter, and bluer, has been orbiting Betelgeuse on a nearly 6-year cycle, close enough to actually pass through the red supergiant's enormous extended atmosphere as it goes. Because Betelgeuse's atmosphere is so vast, because it stretches out into space for hundreds of millions of miles, a companion sitting at only a few astronomical units away is not really outside. It is partly inside. Pause with me here. We are 3,000 words into a video about a star you have probably only ever glanced at, and I'm willing to bet you have already felt something shift. The kind of shift where you remember, very vividly, what it felt like to be a kid and look up and not know what was out there. If this video is doing that for you right now, share it with one person in your life who still asks questions about the sky. Not because of the algorithm, because someone you know is about to walk outside tonight, glance at Orion, and have no idea that the most famous shoulder of the most famous hunter in the sky just turned out to be two stars dancing together in slow motion. Send it to them, then come back. The second half of this is going to change what the word supernova means to you. The companion was given a name, Siwarha, from the Arabic word for her bracelet. Betelgeuse itself, which most English speakers pronounce to rhyme with juice, actually comes from an Arabic phrase meaning something close to the hand of the giant. In old Arabian sky legend, that giantess wore a bracelet. The smaller star, the one orbiting through her atmosphere, the one trailing behind her in steady 6-year loops, was named for that bracelet, Siwarha. The name is poetic, but the science behind it is anything but. What makes Betelgeuse's companion extraordinary is not that it exists. Binary star systems are common in our galaxy. Roughly half of all stars live in binary or multi-star arrangements. What makes this one extraordinary is the visibility. Because of the way the companion's gravity pulls on Betelgeuse's outer atmosphere as it swings by, it generates something astronomers have been searching for decades to find. A wake. The same kind of wake a boat leaves behind as it cuts through water. The companion plows through Betelgeuse's chromosphere, its outer envelope of dense gas, and leaves behind it a disturbed, compressed, denser trail of material. And that wake shows up in the light Hubble receives from the star. How does it show up? The way starlight tells its story is through spectrum. When light passes through a spectrograph on a telescope, it splits into its component colors. Each chemical element in the star's atmosphere absorbs specific, identifiable wavelengths. Changes in those wavelengths, shifts in either direction, reveal how the gas is moving. If it is moving toward us, the color shifts blue. If it is moving away, it shifts red. That is the basic physics of Doppler shift. What Hubble detected in Betelgeuse's spectrum, over nearly 8 continuous years of watching, was a repeating pattern of disturbance in the movement of gas. Disturbance that lined up perfectly with the orbital period of the companion. Roughly every 2,100 days, shortly after Siwarha passed in front of Betelgeuse from our perspective, the wake became visible in the data, then it expanded, then it faded, as Siwarha moved to the far side of its orbit, and then, 6 years later, it showed up again, and again. Across at least 2 full orbital cycles of Hubble observation, the pattern repeated. The wake was not a hint. It was not a single sighting. It was the same signature, showing up exactly where orbital mechanics predicted, twice in a row. The lead researcher, Andrea Dupre of the Center for Astrophysics at Harvard and Smithsonian, who has studied Betelgeuse for decades, summed the discovery up plainly. Finding the wake from its companion, she said, means astronomers can now understand how stars like this evolve, shed material, and eventually explode as supernovae. Just that. Just one sentence, and inside that sentence is essentially an entire rewrite of how we model the largest class of dying stars in the universe. What does the companion actually look like? Smaller than Betelgeuse by a factor of hundreds, somewhere between roughly 1.4 and maybe 2 or 3 times the mass of our own sun. Hotter? Bluer. A young, still fusing main sequence star that, in pure physical scale, is roughly the size of our sun, or maybe slightly larger. Sitting next to Betelgeuse in a fair comparison, the two would look like a sphere the size of a sports stadium set down beside a beach ball. But the orbit itself is where the strangeness concentrates. Siwarha sits at roughly 4 times the Earth-Sun distance from Betelgeuse. That is about the same relative distance that Jupiter sits from our own sun. It sounds safe. It is not. Because Betelgeuse is so enormous, the 4 times Earth-Sun distance does not put Siwarha outside the star. It puts the companion partly inside Betelgeuse's outer atmosphere. In 2025, astronomers using the Gemini North Telescope in Hawaii captured what appears to be the first direct image of Siwarha, a faint candidate, dot visible right next to Betelgeuse at exactly the place the orbital models predicted it should be. The image was not sharp enough to be considered a clean, independent confirmation. It was marginal. Atmospheric distortion and the overwhelming brightness of Betelgeuse itself made the data hard to lock down. Then in 2026, using the Very Large Telescope in Chile, one of the most powerful optical systems currently operating on Earth, researchers captured even clearer evidence. That work was published in a peer-reviewed journal and described by the European Southern Observatory as the strongest evidence yet that the companion exists. 2 independent telescopes, 2 different continents, 2 different observing teams, 1 consistent picture. There is still one more check the science wants. The next major viewing window for confirmation lands in November 2027, when Siwarha will be at the widest apparent separation from its host as seen from Earth. Multiple research teams have already been granted telescope time for that window. Hubble will almost certainly be pointed at Orion's shoulder that night. The Very Large Telescope will be. Gemini North will be. If the 2027 window delivers what the 2024 wake data, the 2025 candidate imaging and the 2026 direct imaging all suggest, the binary nature of Betelgeuse will be established beyond any remaining doubt less than 2 years from now. The calendar is already marked. And here is the part that genuinely reframes what we thought we knew. Before Sawarha was confirmed, some of the strange behavior astronomers had been measuring, the brightness cycles, the dimming events, the outbursts, all the things that felt like a star racing toward catastrophe, had fueled a popular speculation. That speculation said Betelgeuse might be much closer to exploding than previously thought. That was wrong. What was actually happening was gravity. The companion was stirring the star's outer layers every 6 years, pulling material around, perturbing atmospheres, creating patterns that looked from a single star perspective like a star in mortal distress. But the new understanding, with Sawarha factored into the models, places Betelgeuse in what astronomers call a stable helium-burning phase. Its core is fusing helium into heavier elements. That phase lasts a long time. The current best estimates place the actual supernova anywhere from tens of thousands of years to about 100,000 years in the future. Not tomorrow, not next year, not in our grandchildren's lifetime. Across a span of time so vast that no human alive today will see it. But Sawarha will not survive to see it either. Long before the supernova, tidal interactions between the two stars, the gravitational pull of Betelgeuse slowly reaching out, dragging the smaller companion's orbit inward year after year, will pull Sawarha closer. Within roughly 10,000 years, possibly, Betelgeuse's outer layers will have engulfed the companion entirely. The smaller star will not escape. It will be swallowed. And even that, when it happens, will be an event without any known observational parallel in all of human astronomy. A red supergiant consuming another star whole. Beyond Betelgeuse itself, the discovery has implications for one of the longest standing puzzles in stellar astrophysics. It is called the red supergiant problem. Theory predicts that massive red supergiants should be the most common stars to end their lives in core collapse supernovae. They sit at the top of the mass range. They are the obvious candidates. Yet when astronomers compare the pre-explosion photographs of stars that have actually gone supernova against what theory predicts those stars should look like, the match is poor. Some of the stars that exploded should have been red supergiants on paper, but were not. Some simply did not appear where the models expected them to. One massive star discovered earlier in 2026, sitting in a galaxy 2.5 million light-years away, apparently faded out and collapsed directly into a black hole with no bright supernova at all. A slow cosmic goodbye instead of fireworks. The leading explanation now is that hidden companions, exactly like Sawarha, may be the missing piece. If many massive dying stars are actually binary systems, the gravitational influence of the companion can change how the star loses mass, how its outer layers behave, even whether it produces a visible supernovas at all when it finally collapses. Betelgeuse has just shown astronomers what was missing. They are now looking for it in every other massive red supergiant they can point a telescope at. The picture at the end of all of this is strange and quietly emotional in a way that is hard to name. Tonight, if you go outside and find Orion, look at the red glow at the upper shoulder. Lift your hand, hold your thumb up at arm's length, and remember that what you are looking at is not one thing. It is two stars, locked in a 6-year dance, one of them so enormous it would swallow everything between us and Jupiter, the other so small by comparison that it looks like a child's marble next to a cathedral. The light that is hitting your eye right now left Betelgeuse before the printing press existed, before the Renaissance, before telescopes, before any of the instruments existed to even suspect that something was moving inside it. And inside that light, dated like a letter sealed at the source, the signature of a companion star has survived 650 years of interstellar travel to tell us, very quietly, that we have been wrong about what we were looking at. Not wrong in the small way. Wrong in a way that propagates outward through every model, every simulation, every prediction we have ever built for the largest class of dying stars. If this video made you feel the size of the universe tonight, pass it along. There's somebody in your feed who would watch it twice. In November 2027, when the biggest telescopes on Earth and the most famous telescope in orbit turn their instruments toward Orion's shoulder, at the exact moment Sawarha swings into its widest observable separation, we will know more. We will know more about the wake. We will know more about the orbit. We will know more about how this strange double star is going to slowly cannibalize itself over the next 10,000 years, and how long after that, when the core finally collapses, the entire system will burn itself into a momentary second sun that will light up Earth's sky. We will not be here, but we will have watched it begin. Hubble is still up there. The Very Large Telescope in Chile is still up there. The next generation of enormous ground-based observatories is already being built. And somewhere, in the next few years, the same kind of companion stars that Sawara is teaching us to look for will almost certainly be found. That work has already begun. Go look up tonight. Look at Betelgeuse. And remember that the faint reddish glow you see is the slow first chapter of the largest single explosion the universe is going to produce. You are watching it begin. You have always been watching it begin. Now you finally know what you are watching.